According to the National Electrical Code, specifically Articles 300.22 and 314.17, all switches must be installed in an approved box or enclosure. Furthermore, Article 300.9 states that metal enclosures shall not be used as an electrical raceway. Additionally, Article 300.11 mandates that where conductors and other electrical equipment are installed in exposed locations, they shall be securely supported. The International Building Code, in Chapter 11, also requires electrical installations to comply with the National Electrical Code. Therefore, mounting a switch in an aluminum frame without an approved box or enclosure is not legal based on the National Electrical Code. The blueprints and notes from an engineer do not override the requirements set forth by the National Electrical Code. This practice presents several potential hazards. Firstly, there's the risk of electrical shock. Conductors could come into contact with the aluminum frame, creating a shock hazard for anyone touching the frame. Secondly, there is a potential fire hazard. Overheated conductors could ignite the aluminum frame, potentially causing a fire. Thirdly, physical damage to the conductors is a concern, as they could be pinched or compressed within the aluminum frame, leading to insulation damage and potential shorts. The recommended course of action is to contact the electrical inspector for the city. Request that the general contractor install the switches in approved boxes or enclosures. If necessary, request that the electrical inspector issue a violation notice to ensure compliance with the National Electrical Code. Proper installation methods, utilizing approved boxes and enclosures, are essential for ensuring electrical safety and code compliance. The National Electrical Code prioritizes safety and provides specific guidelines for electrical installations to mitigate potential hazards. Failure to adhere to these guidelines can result in dangerous situations and code violations. It is always best practice to consult with a qualified electrical inspector and ensure that all electrical work meets the requirements of the National Electrical Code. The use of approved boxes and enclosures protects conductors from physical damage, provides a barrier against accidental contact, and helps to contain any potential electrical arcing or faults. Moreover, using the aluminum frame of a glass office as a chase and mounting a switch without a box bypasses all of these safety features. The purpose of a proper electrical box is to provide a safe and secure location for electrical connections. It is designed to contain any sparks or arcs that may occur, preventing them from igniting surrounding materials. It also provides a means of grounding the electrical system, which helps to protect against electrical shock. Attempting to use an aluminum frame as a substitute for an approved electrical box is not only a code violation, but also a serious safety hazard. The aluminum frame is not designed to contain electrical sparks or arcs, and it may not be properly grounded. The National Electrical Code is updated every 3 years to reflect the latest advancements in electrical safety. It is important to stay up to date on the latest code requirements to ensure that all electrical work is performed safely and correctly. The National Electrical Code is a comprehensive set of standards for electrical installations in buildings. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The purpose of the National Electrical Code is to protect people and property from electrical hazards. The National Electrical Code is developed by the National Fire Protection Association, a non-profit organization that develops codes and standards for fire safety. The National Electrical Code is adopted by most states and local jurisdictions in the United States. It is important to consult with a qualified electrical inspector to ensure that all electrical work meets the requirements of the National Electrical Code. The use of proper wiring methods is essential for electrical safety. Improper wiring can lead to electrical shock, fire, and other hazards. The National Electrical Code specifies the types of wiring methods that are permitted for different applications. The National Electrical Code also specifies the requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. The National Electrical Code also specifies the requirements for grounding. Grounding is the process of connecting electrical equipment to the earth. Branding helps to protect against electrical shock by providing a path for fault current to flow back to the source. The National Electrical Code also specifies the requirements for equipment installation. Electrical equipment must be installed in accordance with the manufacturer's instructions and the requirements of the National Electrical Code. The aluminum frame could potentially become energized if there's a fault in the wiring of the switch. This could happen if a wire becomes loose and touches the metal frame. If someone then touches the energized frame, they could receive an electrical shock. The severity of the shock would depend on several factors, including the voltage of the electricity, the amount of current flowing through the body, and the person's health. Electrical shocks can range from mild tingling to severe burns and even death. Even a mild shock can be painful and can cause muscle spasms. A more severe shock can cause burns, cardiac arrest, and other serious injuries. The aluminum frame is not designed to withstand high temperatures. If a short circuit occurs in the wiring of the switch, it could generate a lot of heat. This heat could cause the aluminum frame to melt or ignite nearby materials. Electrical fires can spread quickly and can be very difficult to extinguish. They can also produce toxic fumes that can be harmful to breathe. The wires that are used to connect the switch are typically insulated to prevent them from shorting out. However, if the wires are pinched or compressed, the insulation can be damaged. This can expose the bare wires, which can then short out against the aluminum frame. A short circuit can cause a sudden surge of electricity, which can damage the switch and other electrical equipment. It can also cause a fire. The purpose of an electrical box is to provide a safe and secure enclosure for electrical connections. It is designed to protect the wires from damage, prevent them from shorting out, and contain any sparks or arcs that may occur. Electrical boxes are typically made of metal or plastic and are available in a variety of sizes and shapes. They are also required to be properly grounded to prevent electrical shock. There are many different types of electrical boxes available, each designed for a specific purpose. Some common types of electrical boxes include outlet boxes, junction boxes, and switch boxes. Outlet boxes are used to house electrical outlets, junction boxes are used to connect multiple wires together, and switch boxes are used to house electrical switches. The electrical inspector is responsible for enforcing the National Electrical Code. They inspect electrical installations to ensure that they are safe and compliant with the code. If they find any violations, they will issue a notice to the contractor or homeowner requiring them to correct the problem. The electrical inspector is a valuable resource for anyone who is planning to do electrical work. They can provide guidance on how to comply with the National Electrical Code and can help to ensure that the work is done safely. It is always a good idea to contact the electrical inspector before starting any electrical work, especially if you are not familiar with the National Electrical Code. Contacting the electrical inspector ensures that the electrical work meets the required standards and protects the safety of occupants and the building structure. The general contractor is responsible for ensuring that all work on a construction project is performed in accordance with the applicable codes and regulations. This includes ensuring that all electrical work is performed by a qualified electrician and that it meets the requirements of the National Electrical Code. The general contractor should have a thorough understanding of the National Electrical Code and should be able to identify any potential code violations. They should also be able to work with the electrical inspector to resolve any code issues that may arise. It is important to choose a general contractor who is knowledgeable and experienced in electrical work. They should also be willing to work with the electrical inspector to ensure that all work is done safely and in compliance with the National Electrical Code. If the electrical inspector issues a violation notice, the contractor or homeowner is required to correct the problem within a specified time frame. If the problem is not corrected, the electrical inspector may take further action, such as issuing a fine or shutting down the power to the building. It is important to take violation notices seriously and to correct the problem as soon as possible. This will help to ensure the safety of the occupants of the building and to avoid any further penalties. Ignoring violation notices can have serious consequences, including fines, power shutoffs, and even legal action. It is always best to correct the problem as soon as possible to avoid any further complications. Electrical safety is everyone's responsibility. By following the requirements of the National Electrical Code and by working with qualified electrical professionals, you can help to ensure that your home or business is safe from electrical hazards. Remember to always be aware of the potential hazards of electricity and to take precautions to protect yourself and others. If you are not sure how to do something safely, it is always best to consult with a qualified electrical professional. Aluminum, while a conductive metal, poses additional risks in electrical applications if not properly handled. The aluminum frame itself is not listed or labeled for use as an electrical enclosure. Listed and labeled equipment has been evaluated by a recognized testing laboratory and found to be safe for its intended use when installed in accordance with the manufacturer's instructions and the National Electrical Code. The National Electrical Code requires that all electrical equipment be listed and labeled. Using an unlisted aluminum frame as an enclosure violates this requirement. Even if the aluminum frame were properly grounded, it would still not be an acceptable substitute for a listed electrical box. Grounding helps to protect against electrical shock, but it does not prevent a short circuit from occurring. A short circuit can still cause a fire, even if the equipment is properly grounded. The aluminum frame could also be subject to corrosion, which can weaken the metal and make it more susceptible to damage. Corrosion can also create a layer of insulation on the surface of the aluminum, which can interfere with grounding. Aluminum expands and contracts more than other metals when exposed to temperature changes. This expansion and contraction can cause the wires to loosen over time, which can create a fire hazard. The use of an aluminum frame as an electrical enclosure can also create a problem with electromagnetic interference, or EMI. EMI is a type of electrical noise that can interfere with the operation of electronic equipment. The aluminum frame can act as an antenna which can pick up EMI and transmit it to the surrounding equipment. This can cause the equipment to malfunction or to produce inaccurate readings. The National Electrical Code Article 314.17 provides detailed requirements for how conductors must enter boxes, conduit bodies, or fittings. These requirements are intended to prevent damage to the conductors and to ensure that they are properly secured. Simply cutting a hole in an aluminum frame and inserting conductors without proper strain relief or protection violates these requirements. The NEC also addresses the issue of supporting and securing electrical equipment in Article 300.11. This article requires that electrical equipment be securely supported to prevent it from being damaged or dislodged. Mounting a switch directly to an aluminum frame without proper support violates this requirement. The switch could be easily damaged if the frame is bumped or moved. The use of an aluminum frame as an electrical enclosure can also create a problem with moisture. Moisture can condense inside the frame, which can cause the wires to corrode and short out. The National Electrical Code requires that electrical equipment be protected from moisture. Using an unsealed aluminum frame as an enclosure violates this requirement. The decision to deviate from standard electrical practices should not be taken lightly. It is crucial to consider all potential safety risks and ensure compliance with the National Electrical Code and local regulations. Blindly following stamped blueprints without verifying code compliance can lead to hazardous situations and legal liabilities. An engineer's stamp on a blueprint doesn't automatically guarantee code compliance. Engineers, while skilled in design and structural aspects, may not always be fully versed in the intricacies of the National Electrical Code. It's ultimately the responsibility of the electrical contractor and the electrical inspector to ensure that all electrical work meets the required safety standards. The engineer's design might have overlooked certain electrical code requirements, or there might have been changes made during construction that were not properly reflected in the blueprint. It is always prudent to double-check the design against the National Electrical Code. In conclusion, while the aluminum frame might seem like a convenient place to mount the switch, it's a practice that violates several key provisions of the National Electrical Code. It presents a variety of safety hazards, including electrical shock, fire, and physical damage to the conductors. The best course of action is to install the switches in approved electrical boxes to ensure a safe and compliant installation. Remember to consult with a qualified electrical inspector and follow all applicable codes and regulations.